We will now explore this particular diagram, start from the chiller. The first is chiller, the importance of chiller in building automation system. We learn details about this chiller and what are the different parameters that is possible to be measured in this particular system. That also we will try to explore. So now some introductory about the chiller. So chiller is mentioned over here by a middle red color indications, and it is the symbol of heart. So you can easily, or we can easily say that chiller is the heart of complete HVAC system. So chiller plays an important role in HVAC system. So in this particular, you can see that there are two types of flows, the upper side and in the bottom side. In the bottom side, if we focus on in the particular section, so it can be seen that the cool water from the chiller that enters in a particular air handling unit, right? This is the air handling unit, and then after air handling unit, the output of the air handling unit is again pumped into the chiller. So chiller chill that waters with the help of this upper part. In upper part, it can be seen that the waters, the hot waters enters into the cooling tower. The cooling tower cools that waters, and it gives to the it enters into the condenser unit over here in the chiller. There are four blocks through pumps. Again, this water from the cooling towers enter into the chiller, where it enters and from where it pass to the cooling tower. That is our part of discussion, as well as this pump, particularly this pump from the air handling unit, where this particular pump gives the output to which part of this chiller, that also we will going to highlight, and from which part of the chiller the chilled water is circulated over the air handling unit. That also we will going to explore, and this is a very important part in the HVAC system. Now this particular figure, again the same type of things. It can be seen that this particular section is a air handling unit again, and you can see that from the condenser, there is a condenser shown over here, and this condenser water supply is there are maybe many types of pumps and chillers that are possible. This particular, I will skip this figure, so there should not be any confusion. So to get a clear idea of the chiller, now we can explore this particular figure. So here the complete picture will be clear to you for the operational. First of all, we try to learn the operation of chiller. So in this chiller, there are four main parts or components of the chiller. A very important part or the component of the chiller is compressor. Again, there are different types of compressors. Maybe we can have the centrifugal compressor or the screw type of compressor. They are mainly involved in a compressor, and compressor selection is also depending on type of condenser. The second important part of this particular chiller is condenser. So condenser is again depending on the type of chiller. So there are mainly two types of chillers. If we found literatures, air cooled chillers and water cooled chillers. So the names air cooled chillers and water cooled chillers are given based on supporting component in the condenser. If the condenser functions with the cooling tower, then we can call that particular chiller as a water cooled chiller. If the condenser is not function with a cooling tower but using a fan, then we can call that particular chiller as a air cooled chiller. Okay, means there are two types of chillers mainly available in literatures: air cooled chillers and water cooled chillers. Means that air cooled condenser or water cooled condenser. So names are based on condenser. If condenser functions with the cooling tower, then it is water chilled. If the condenser functions with the internal fans, then that is air cooled chillers or air cooled condensers. The third important part in this particular chiller is expansion valve, that plays very important role. And the fourth component of the chiller is evaporator. Okay, so these are the four components of the chiller system. And now let us have the closed loop of this particular chiller. So now right from, we can say that the compressor feeds the refrigerant in the form of vapors to the high pressure, high temperature vapors. It compressed, or it discharged to the condenser. Then there is a separate tubing for the tubing in the condenser for the external cooling tower. So this particularly the cold water will enter in this particular section into the condenser, and the heat get dissipated into the return phase of this particular pipes, and then the cooling will be taken place in the cooling tower. So this flow to cooling tower, this goes to the cooling tower, where this in temperature, this particularly the in temperature, maybe we can say that 27 degrees Celsius is the in temperature for this particular refrigerant coming from the compressor. And then heat exchange taken place in this condenser. There is no mixing, there is a separation. Here heat exchange taken place in the condenser, and maybe the output temperature is raised, and that is around 32 degrees Celsius, and it goes to the cooling tower. Cooling tower functions, this discharges the heat to the atmosphere, and again the temperature reduces to about 27 degrees Celsius. And this particular compressor gives the vapors in the form of high pressure and high temperature. So this is the role of compressor, that provides refrigerant in the form of vapors, where the condenser converts that particular vapors into liquid form. Means there is a conversion and heat exchange taken place. So the output of the condenser that is available here, the output of the condenser that is in the liquid form, the output of the condenser is in the liquid form, that passes through the expansion valve. The expansion valve function is to regulate the flow rate of that refrigerant, liquid form of refrigerant required for the evaporator. So how much amount of chilled water we have to provide to air handling unit, that is another component from the evaporator. So how much amount of chilled water we have to be provide, what degree Celsius of chilled water we have to be provide, that rate can be adjusted by the expansion valve. So this is expansion valve. Expansion valves gives the liquid form to the evaporator. Evaporator is also one type of heat exchanger, where some form of the vapors are also present. Some maybe 10%, 5% to 10% vapors are remain there. There may not be 100% condensation taken place in the condenser. So that particular evaporator evaporates that 10 to 5 to 10% of the vapors, and that are again discharged to the compressor. And here what happened? The return to the chiller, means this particular supply of the, we can say that the water, chilled water, that is coming from the building. Actually this is coming from the building, this is coming from the building, that particular temperature may be around 12 degrees Celsius. So this is a higher temperature, not very higher we can say, but this is actually the exhausted temperature from the building areas, from the air handling unit. discharge, we can say that the line is the water line, discharge water line, that liquid temperature is around 12 degrees Celsius. And here what happened again, because of the refrigerant that enters through the expansion wall, the temperature is around, we get 10 to 12 degrees Celsius. So 10 to 12 degrees Celsius is the temperature that actually we chilled to this particular values by the evaporator, and the remaining we can say that is given to the refrigerant out is given actually to the evaporator. So compressor. So compressor has roles, important roles. The compressor provides as at the entering of this particular is the low pressure and low temperature. We can say the low pressure and low temperature vapors that actually enters here over here in the vaporization, and because of the compression, it converts that particular refrigerant into high pressure and high temperature. That is the main function. So during this conversion, there should not be any effect on the evaporator. That is also the role of compressor. So this is a basic idea of this particular core part of chiller. So compressor gives high pressure, high temperature to the condenser. In condenser converts that vapors into the liquid form. Liquid form of refrigerant enters through expansion wall into the evaporator. Evaporator plays very important role. Some of the vapor part is again discharged to the compressor, and it also provides a cooled water supply to the whole building, and actually not directly to the whole building, but it provides to the air handling unit, and after that it is distributed over the building. So the requirements are also mentioned over here. The chiller in this condenser, the associated component is cooling tower. If the type of chiller is we can say that water cooled chillers, right? And if the chiller is not water cooled, then this particular condenser is different. Here what picture is in front of you is an example of water cooled, and that is most popular type of chillers. Okay, and fan type of chillers or air cooled type of chillers diagram is somehow different. There is no return and chiller and that this particular lines over there. That the function of exchanging is taken place with the help of fan in this particular chiller sections. Now one more diagram as per the instrumentation point of view. So we can say that there is a pressure relief valve, there is a high pressure switch, there is a low pressure switch, there is pressure transducer, then there is a liquid shut-off valve, there is expansion valve, there are many temperature sensors, and there is a flow switch also there, pressure gauges are also there. So all these particular measurement part is involved in particular chiller. So this is some graphical picture of this animation of this picture of this particular chiller. This is what? This is compressor. This top part is compressor. Okay, this is compressor. In compressor, it can be seen that large electrical motor is connected. Large electrical motor. This is the back side. This black color. This is particularly a large electrical motor in the centrifugal type of compressor. And now you maybe say that the output of compressor is connected over here. You maybe say that the output of compressor is connected over here, but this is not the thing. Okay, so this middle part is not actually the output of compressor. Where it goes? Output of the compressor, where it goes? Chiller, sorry, condenser. Output of the compressor goes to the
condenser.
So you may be say that this is condenser. You may say that this is output. No, that is not there. But what is this? This is the input to the compressor. This is input to the compressor, not output from the compressor. So input to the compressor is from which part? Input to the compressor. Which gives input to the compressor? Evaporator. So what is this black portion? Evaporator. This is evaporator. Okay. So this is evaporator. That is this particular evaporator is in the middle part. Okay, insulated evaporator, so that the color is black. This particular color is black, so that we can call it insulated. Okay, insulation is provided, so there should not be any dissipation to the surrounding. So this is evaporator, and you can see this particular cream color type of lower section, right? This one. So what is this?
Condenser.
Condenser. Very correct. This is condenser. So now this is the front side. Now I will show you the back side, so that you will get idea that from compressor how it is connected to the condenser, because compressor output is connected to the condenser through which one? Through expansion wall. So you can see over here. Yes. Yes, this is one more picture I added to clarify you that this particular is the compressor, right now. This is the compressor. So compressor, this type of centrifugal mechanical structure in this particular compressor. So intentionally I added the internal structure of this compressor. So you'll get idea that so what type of armature and rotors are there in the centrifugal type of compressor. So you can see this particular diagram is the actual diagram actually in this. Yes, now maybe you clarify from this particular diagram. Yes, I will show you again. Yes. This is compressor. This is input to the compressor from evaporator, and this is condenser. Okay, and you can see in this. So you can see that yes, where is that particular expansion wall? Expansion wall is not shown. Yes, you can see the from this particular picture. So this compressor gives output to this expansion wall. This is the expansion wall located here. This is the back side of the picture, and earlier was the front side of the picture. In the back side, it is clearly seen the expansion wall, and the expansion wall you can see that connected to the evaporator. Okay, it's connected to the evaporator, and expansion wall is from the means output of compressor is connected to the condenser, and condenser output is connected to evaporator expansion wall, and this expansion wall output is connected to this particular evaporator last. And this side you can see that there are pipes connected over here. So there is a one pipe is for the inlet and another pipe is for the outlet. So now here also you can clarify that there are two pipes, right? One pipe in the evaporator that is coming from the building, and one pipe goes to the building. So this may be incoming and this may be outgoing pipe. And the same you can see for the condenser also. There are two pipes connected here. Two means one is coming from the cooling tower, right? And one goes to the cooling tower. The temperature of the refrigerant is higher from the compressor, and that is in the vapor form. So in condenser, there is a conversion of vapor form into liquid form with low pressure, low temperature. Correct? So during the conversion, there is a heat exchange taken place, and that heat get exchanged to the cooling water, tower water. That heat will get exchanged to the tower water, tower's outlet. So that outlet temperature of the cooling tower is higher. And again, it goes to the actual cooling tower that I have not shown over here, where that heat get dissipated to atmosphere, and again the temperature comes to their normal value or desired value, and then it enters into the condenser. This is the continuous cycle.